Okay, we're going to look at graphing using intercepts. Okay, and when we talk about intercepts, we're talking about, and this is linear, a linear line, when the line crosses the y-axis and the x-axis. And essentially, as long as you have 2 points, you can make a line. Any line, right? Any 2 points, you just connect the two of them, and you can make a straight line. So that goes without saying that if I have a y-intercept and an x-intercept, I have a line. Or y-intercept and an x-intercept, I have a line. Right? So if I can find those two, I can graph any line. We're used to graphing in the form of y equals, and they usually do m, and then x plus, they usually use b, right? B as our y-intercept. So we know one of the ways we could tactically do this is to set this equation equal to y. This is in standard form. If we change it to y-intercept form, we can find our y-intercept very quickly. So we'll do that, but I'm going to show you another way to go through this whole process. So let's take this original equation in standard form. Okay, this is in standard. Okay, and we're going to set it equal to y. So take the equation x plus y minus 4 equals 0. Well, if I move negative 4 to the other side, what will it become?
Positive 4.
Yeah, and if I move the x to the other side, what will it become?
4 minus x.
Yeah, 4, and you say negative x. So in other words, we're going to get y is equal to, and a lot of the times, just to keep it in line with this, they put the x first, so we'll say negative x plus 4. But if you wrote 4 minus x, exact same thing. That means our y-intercept, which we already know, is positive 4. And our slope is negative 1, which means we go down 1 over 1. Down 1 over 1. And voila, we have our lovely line. Let's see if I can do a decent job of drawing this. Yay. Not bad. Not bad at all. Okay, so there's our line. But there's a whole other way we can go about this. And the way we can look at this is a y-intercept is always when the x value is what? What is the x value right here? At this line, when we're on the y-axis, what's our x value?
0.
0. This is when x is equal to 0. And our x-axis, what's our y value here on the x-axis?
Wait, right on this side?
Yeah, we'll write on the x-axis. What's y?
Oh, 0.
0. Y is always equal to 0. So what that tells us is that we can solve for, in any form of the equation, we can solve for a y-intercept by setting x equal to 0 in the equation. And we can solve for an x-intercept, and maybe I'll change the color for that. An x-intercept by setting y equal to 0. So let's take that original equation we had. X plus y minus 4. Alright, so this is the equation. X plus y minus 4 equals 0. Right? Okay, so what we're going to do here, okay, so we have our equation, and like we said, if we set x equal to 0, so we take the x value, and this will be our first version. If we set this equal to 0, so we put 0, replace x with the value of 0. If we solve for y, that'll give us the y-intercept, okay? So when we do that, we'll get 0 plus y minus 4 equals 0, right? Well, what's 0 plus anything? Do I need to really write it in? No, it changes nothing, right? So we have y minus 4 equals 0, and if we set it equal to y, what does 4 become on the other side?
4.
Positive 4, which is exactly what we found when we did the equation before, right? We found that our value is 4. The next thing we could do is find for the x-intercept. So we'll call this equation 2. We write the exact same equation, x plus y minus 4 equals 0. But this time what we're going to do is we're going to set y equal to 0 and solve for x. Okay? And what that'll do is give us an x-intercept. So we replace y with the value of 0. All right? And we get x plus 0 minus 4 equals 0. Do we need to include that 0?
No.
No. So what does this become? X what?
X minus 4 equals 0.
Yeah, x minus 4 equals 0. And what does 4 become on the other side?
Positive 4. 4.
Yeah, so it just so happened the x and y intercepts both happen to be positive. And look at that. When I drew my line, that's exactly where it was. So the actual coordinates of these, okay, our y-intercept was actually at 0. Remember, our x value is 0, and our y value is 4. And the x-intercept, it's kind of confusing because we happen to get one that had the same numbers, but our x value was 4, and our y value was 0. So technically, if I had just plotted those 2 points, this being my x-intercept at 4 and 0, and my y-intercept, which was at 0 and 4, right? Those 2 points, we could have, again, connected those 2 points and got our line. Okay, so whether we put in the y equals mx plus b, or if we're in a form that's not like that, we can just plug in zeros for the x's and y's and solve for the intercepts, plot 2 points, and connect them.